Welcome to the Industrial Talk Podcast with Scott MacKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, once again, thank you very much for joining Industrial Talk. Thank you for your continued support of a platform that celebrates industry professionals all around the world. You are bold, brave, you dare greatly, you innovate, you collaborate, you solve problems. That's why we celebrate you. You're making the world a better place. That's why we just love you on Industrial Talk. We are broadcasting from DISTRIBUTECH here in Orlando, Florida. And it's day 3, wrapping up. People are still milling about the place. It's still got a lot of energy, of a bunch of problem solvers here. In the world of energy and utilities, that's what it's all about here, big time. In the hot seat, we have the doctor, Dr. Dominic Kohler. He's in the hot seat. We're going to be talking about a new product offering coming from Siemens, and he's going to go into details. I don't have to do that, so that's his responsibility, not mine. How you doing?
I'm fine. It's great to be here.
It's great.
Thank you.
Great to have you. You were all over in the other. How far away is?
That's a half an hour drive by car. We're there with our user group meeting.
Yeah.
For our portfolio with all the utility planners.
Yeah,
planners. Yeah.
Yeah, we were. You had a wonderful event. I was surprised at how many
Last
people were
night,
there.
right?
Yeah, it was great. We went to Epcot.
Yeah. We also had the metadata management colleagues and the protection user group meeting. Yeah, it was just great.
That was off the chart. All right, before we get into the topic, Dominic, was that user community?
The user group meeting, we call it.
Was it productive?
I actually loved it a lot. You know what? We have this network model manager that we are talking about today. Yeah. But we also released like 1.5 years ago our first cloud offering. And it was just so incredible to see how the industry is picking up now. We had like 1.5 hours as a slot, us presenting a bit to our customers, like first customers now using it. And we had so many questions, like the 90 minutes were not enough. We had to cut it short in the end.
No way.
Yeah. And we had to then take more questions in the break.
So cool.
It's cool to see how the industry picks up on cloud and the new technology, right?
It is awesome. All right, for the listeners out there, let's cut to the chase. Dominic, give us a little background on who you are, and then we're going to go into this network modeling manager and what that's all about.
Yeah, so my current role is I'm the product manager, the head of product management for the power system simulation suite at Siemens. We are part of the business unit grid software within Siemens, and we help our customers plan the power grids. We do basically modeling and simulation so that our customers can study how the power grids behave.
Go ahead.
No, sure. And you asked me who I am, right?
Yes, so I want to know. That's where I was going. I'm going, that's all great,
you just talked about the doctor coming, right? The US guys usually make fun of that. The Germans always write this on their business cards, right? So I'm a doctor in mathematics, actually. I used to do a lot of simulation technology back then in my PhD times. Back then we simulated water grids, and now we're looking at the electricity side.
Oh, fantastic!
In the meantime, then I discovered my passion for the business side, and I was a consultant. And now product management is for me bringing those two worlds together, the technology and the business side, and talking to customers and really identifying how this technology can be used.
Here's the challenge that I always have. This is the segue into your solution, just because it is a dynamic world out there. In the world of utilities, it's dynamic. It's distributive.
I fully agree.
I, as a system operator, I wasn't one, but I know what the system operators. What a challenge! What an absolute challenge! You have all of these renewables, and if we're trying to be net zero in a certain period of time, how do you ensure quality of power, achieving those objectives, distributed energy, all of that stuff? Take us through why, from a network modeling manager, just start taking us through that.
What you're asking is the holy grail, right? How do we do all of this? And we have one contribution there. One contribution, but one of the things you want to have as a utility to model this, to start looking into how renewables help to the grid and how the challenges can be overcome, is actually to, first of all, model how the grid looks like. If you want to install a new renewable plant, say a wind farm or so, you better model it and simulate what's going to happen. And whenever you want to really do analysis and simulation, all these kind of things, the starting point is always just knowing what is where, what those parameters are. And that's what actually model management is.
I like the fact, see, can your solution take existing asset base, and an existing asset base, say I've got some wind farm, I got the solars, I've got all of these renewables that exist and they're on my grid. Can we perform the simulations to optimize the way those interact with the grid?
That's what it's about. So the starting point is the as-built model, right?
Yep.
And then you have, as a grid planner, for all the multitudes of different scenarios. You have thousands of scenarios. There is more load there is more renewables there, and so on. For all of those scenarios, you have then ideas on how you can improve the grids to actually then include those new loads or generation. And now for this multitude of all those different changes to the grids, you somehow have to track them and manage them. This is what model management then is. All those changes, all those incremental changes as to how they compare to the base case, managing this over time, that's the model management basically.
See, this is so fascinating because a number of the conversations I've had here at DISTRIBUTECH have been wrapped around the speed at which the market is changing.
Right.
Like my conversations associated with what was taking place within the utility energy space 2 years ago is completely different than it is today.
That's
2 years.
That's what we see as well.
And when we start talking about model management and simulations, that's an ongoing thing.
It is an ongoing thing, and that's actually a good point. This is not new. So we as Siemens have been offering a model management solution for 10, 15, 20 years. But the thing is now we are now releasing the next generation of network model management, and the change basically is we make use of all the new technology that's out there. So we have a next generation UI, we have it cloud ready, we do have interoperability. So in the past this was all manual stuff that you had to do. Now it's automated with APIs, really using the new technologies. That's the change that our customers also rightfully are asking from us. You know what? This morning I'm coming out of a session back in our user group meeting, and one of the talks was about how they want to use the new network model manager, and then this guy told me, "Look, Dominic, a model is always wrong, but sometimes it's helpful. Help us get it more helpful." And I just love this, right? So there has always been a model, and now we want to make it better, higher quality, so that you can really run the simulations that are needed. I just love this guy, one of our customers there. Yeah.
When you say we look at the as is or as built, and you have to run those models, I would imagine. How do you begin to feed the model with specific data? There's the as-built, but then there's the economic component of saying, hey, this area is building out. Hey, we see a projection that there's going to be X, Y, Z over here. You have to take that all into consideration, right?
That's actually true. So you have to look at the transmission and at the distribution side a bit differently. So the transmission side is traditionally you take network models from asset management tools, from SCADA systems, and then you feed this into a network model manager, and then you make sure with this, what people then like to call the single source of truth or a digital twin, they then take the data and then they feed it into all the systems, into planning, into operations, into protection systems, and so on. So that's the transmission side. On the distribution side, the change is actually much bigger.
Oh, it's massive.
There is so much more happening that has not been there in the past, and also for the model management that's different. So on the distribution side, there is sometimes no existing grid that you have in a SCADA system or so. So what you have to do there is start from a GIS system or so, take the geographical data about what is where, and then start to develop a network model that has then electrical parameters, and that you can then start also using for simulation.
Do you have to upload the assets into that? It's like there's modeling, but that's a physical transformer. This is a reclosure. This is, all of the assets.
That's what you're modeling.
You have to pull all that stuff in.
That's what you're modeling. So look, this is the interesting thing about this is not a model of an asset with thousands of parameters for one asset. This is rather like tens of parameters per asset, but then for thousands, hundreds of thousands of assets in a power grid. It's a huge, huge system. People actually say this is one of the biggest machines, or if not the biggest machines, that humankind has ever built, such a power grid, right? So modeling this is on a right level of abstraction that you can still do the simulations there. I actually find this so fascinating, you know, with my background in simulation, those huge systems. Yeah, that's cool.
The huge systems that have been around for years and years and years and years and years, and that have certain ratings and degradation and all of the stuff that's associated with it. I don't know how does a utility, let's just use them as a user.
That's our primary customer.
That's right. So I'm a utility, and how difficult is it to say, hey, Siemens, come on over. We want to begin doing this because we're having whatever the business reason is. Take us through that sort of process of working with the utility.
Right. So that is actually for a utility a big question. How do you, because this can be a major effort, right? So how do you get value out of a pilot project or so immediately? So for example, one of our big customers is Fingrid in Finland, but also AEP in the US. And they are all starting small with one concrete value add. So for example, they start connecting the SCADA system, the EMS, to the network model manager and start filling the network model manager and then pass it on, say, to planning. So then you have now the same model being used in operations and in planning. So in planning, you know what is really the starting point for all your incremental changes to the grid, or in the planning side, you can then commit to that's the change that we're going to implement, pass it on to the operation side, and then those guys can use it. So higher efficiency, higher data quality. As I said before, this is also a lot about automation. In the past, those guys have been sending emails back and forth. And well, with this model manager, REST APIs, you can get access to it right away, pass it on, notifications, all this good stuff. You know what, actually when we introduced this 2 days ago or so, we had our first big launch about this, and one of the things we said is, you know, I said it before, I was in simulation, right? Yeah. Mathematics and so on. You might have heard about Alfred North Whitehead. It's a 20th century mathematician, and he actually said the one KPI or one indicator of how a society evolves is how many processes can be automated. And if you think about this way, this model manager automating how data flows in the different systems, it's quite remarkable what the whole industry is doing here. Like the level we're getting to, it's amazing.
But it has to happen. We have to be more efficient with the network, our grid. If we're to achieve, because there's so many points of pressure impacting the grid itself, utilities. There's just constantly changing. You have to drive out inefficiencies as much as you possibly can. Get to a point where you know that the network is operating at its optimal.
I very much agree.
And then go from there. But you have to drive it out.
I very much agree. So it's about efficiency. It's about data quality.
Yes.
It's finding the right spot for where to include all those renewables, having the right simulations, all accessible then at the fingertip, basically, what you want to do.
How do you deal in the world? No, this draws upon my past experience with the utilities. What is in-house, the diagrams, the maps, all of the stuff that's in the house can very much differ than what's out there in the field.
That's a great point. Actually.
There's a disconnect.
That's true.
And these don't get updated. But anyway, how do you deal with that?
That's the as-built versus the as-model state or so, right? And this is actually exactly one of those points. So the value that our customers get out of this, and that's always the center point for what we're doing, right? The value is that you get an aligned knowledge across the company of what actually is built out there, and then you start from this making all the changes. So the planner knows that's really out there in the field and starts making the changes there. The operations guys is starting from what is really built there, starting to evaluate the switching states or evaluate switching strategies and so on, all based on what is actually built out there. So this is why this is actually so important for us.
You can't upload or whatever connect to bad data. You can't say, you want to make sure, you want to validate that that switch is out there at that particular location, and that has that type of rating, right? Or whatever it is, or that transformer, that pole top, whatever it is.
And validation can have many dimensions. So validation can mean you kind of, first of all, you check that the data fields for the parameters are not empty. Then you want to run a power flow and want to see if this is really a good configuration of the parameters that you have. So this is kind of the things we are then putting on top, right? As you rightfully say, the parameters need to be correct, the data quality needs to be there, otherwise bad data in, bad data out, right? Then the simulation is not really helpful.
Wow. And go ahead.
No, I was just thinking, the other thing that we are now doing is, I said it before, right? We have been offering this network model manager, and this is now where my engineering heart starts beating. We have been offering this for 10, 15, 20 years, right? So there has been almost a monolithic software, and rock solid and proven in implementation by customers. They're using it and very happy with it. But now the challenge with this new technology for us really was, how can we now take this monolithic software, make it modular, slice it apart, right, and then introduce our new technology around it, kind of wrapped in certain pieces, put this together, put this on a new cloud stack, have APIs accessible there. So this is also what then our whole R&D teams, together with our co-innovation customers, have been discussing. In the end, this is software from engineers for engineers, right? This is this is also what the discussions are now about.
I'm super geeky when you can simulate.
So am I.
I'll just eat that all day long. I don't care what it is. Can I do some? What if I did this? What if it's this? And I place this out there? What is it? And just, does the model sort of help with that optimization? Like, instead of me just playing around with the data, it says, hey, let me make a recommendation for you and do this.
You have all the right questions, right? So, I mean, right now, and that's what we've been doing in the industry for quite some time, is the engineers use the simulation technology and then use their engineering brains kind of and the magic to find out what the changes might be, and then start evaluating what they exactly need to be in detail and so on. And now, if we now kind of look into the future, like where this can take us, this is then all those new technologies around AI and so on, right? Do we have the possibility to create a recommendation engine for the engineers? So say, as an engineer, there will be a new power plant at this part of the grid, and then the system in the future might tell you, okay, that's the place where it is, and you need to have three options. You might want to have a substation in addition there, or you might have those and those changes. And then as an engineer, you just kind of check what the machine is actually proposing to you. And this is is probably a bit further out. This is general AI, but on the other hand, then Gen AI in the sense of generative AI. These are things we're also looking into, like how can the simulation system kind of help you with documentation accessible with natural language almost, right? You type in, I want to increase the some load there.
Yeah.
Where do I have to model this? Like which buttons to press in the software, and then you get some kind of responses there. But that's kind of next things to come, right? With we're of course piloting here and there and trying out things, but that's not in the market yet.
Yeah, but it has to happen.
I think, and it will. Our customers rightfully ask for it, right? I mean, that's the technology. This is also why we're now launching this next generation model manager. The software has been there for a couple of years, as I said before, but now with cloud and all those things, that's the first step we're introducing. But now it's a future-proof technology platform, a tech stack that we can then build other things on top.
Yeah, I don't see if we're tasked to achieve a certain level of whatever the net zero and increase the capability of 3x, whatever all of those, all real. That is an efficiency conversation.
Those changes that everybody talks about the energy transition, and to be quite honest, this is why at least I myself and many of my colleagues get up in the morning and do our work and love working with the software that we put out there for the energy transition. But everybody's talking about it. In the end, those concrete instances of kind of mind-blowing changes out there. So, for example, I was just talking to a partner from Australia yesterday, right? We had a chat and so on, and then he told me they are having so much new generation, renewable generation in Australia, that they have to kind of start looking into building an own transmission grid just for this. This is just so many changes. Or another one, now we're in the US here, right? There is HECO, Hawaiian Electric.
Yeah.
They now have plans to go fully renewable, 100% renewable, and they are kind of now looking into how does the system actually have to behave then. So they're using some of the Siemens technology to assess what the grid is, then to optimize with, if you have renewables, those IBRs, you have then changes and you have fluctuations from the AC-DC coupling and so on. All those dynamic phenomena you have to control, you have to optimize. There is, these are the concrete instances that make me really think there is a huge thing happening there on the transmission side, and even more so than on the distribution side.
Yeah, and the reality is that it almost gets down to something simple. I'm a consumer of power, me, Scott. I go to my house, I flip on the light, everything's good. I don't want to come to my house.
That's what you want to have.
Yeah, that's right. I don't want to go to my house and flip on the light and it flickers. It does something that I don't like, and something's wrong. And then if it happens with more people, then whatever effort is being taken, you have to do this right. Absolutely.
One of our users told me yesterday, we're here in Orlando, right?
Yeah.
So there is all this Disney World around.
Yeah. Oh yeah.
And he told me, when I was young, I always wanted to be one of those, I think you call it Imagineers, right?
Yes.
They build all those things, and then he said, yeah, it hasn't really worked. I'm not an Imagineer, but at least I make sure that Disneyland is powered and that it is energized. How cool is that, right?
Absolutely.
Keeping the lights on.
Keeping
the lights on.
You were just an absolute. You were the bomb, Doctor.
Oh,
thank you. Delivered.
You are the bomb as well. Thank you. It was a pleasure.
How do people get a hold of you?
I think the best way is just via LinkedIn.
You are out on it.
Oh yeah, for sure.
Good.
We can perhaps put it on the notes of this interview. Yeah. Thank you so much.
Shoot, Dominic, you were fantastic. All right, listener, we're going to offer all the contact information for Dominic out there on Industrial Talk, so fear not. Reach out to him because it's all about education, collaboration, and innovation. He brings all three of those components to you, so reach out, talk to him, and then do some innovation. All right, we are broadcasting from DISTRIBUTECH. It is in Orlando, and we're going to wrap this conversation up on the other side, so stay tuned. We will be right back.
You're listening to the Industrial Talk Podcast Network.
Dominic. Dr. Dominic. Make a note of that. Was he great? There's a lot of great stuff happening. I mean, when you listen to what's happening at Siemens, about the ability to be able to simulate, to access that data, that information. And I'm telling you right now, in the world of grid management and what's happening in the utility space, this is vital. This is vitally important right there. Dominic, contact information all out on Industrial Talk. You know that. I'm not going to. You just need to connect. It's all about the connection game, right? Finding those incredible Sherpas to help you along on the journey. Dominic fits that. Siemens, great company. You know it. All right, we're building a platform. Industrial Talk is that place. You need to reach out to me. Go out to industrialtalk.com. Say, Scott, I want to talk. Amplify my voice. Be bold. Be brave. Dare greatly. Hang out with Dominic. Change the world. We're going to have another great conversation shortly.